Good morning and welcome back to Science. I hope you had a great time last week starting to learn about the solar system. And this week you found learning about gravity and mass and weight in space also thoroughly interesting. Today I'm going to set you off with three practicals that you can do together at home, I hope, or at least you can watch these to get a feel of what's been going on. And this shows some of the things that you have been learning already this week about craters and about asteroids and about weight and mass and gravity and how all of that comes together to make some of the quite interesting textures of some of these planets and moons in the solar system. So, you have in your work pack this experiment sheet with space for three different experiments. Now what we're going to do today is change one of the control variables at a time in order to make these experiments similar but quite different. Going to investigate different things each time and see how big our craters are going to be on our planet surfaces. So, fill this one out at the very top. Firstly, we're going to change the mass of the asteroid. So we're going to look at whether asteroids of the same size but a different weight will leave different craters on a planet surface. Now I don't know what you've got at home, but here in the centre, this is what I've just found to find three things that are roughly the same size but different weights. Here's a balloon, which will be really light of course. Here is a pool ball, which will be very heavy. And for something quite medium-sized, I've just found a tangerine. So see what you can find that is same size ideally, but very similar and very different weights. Now, remember I said about control variables. Remember what those are? Yes, in an experiment, the control variable is the thing that we keep exactly the same, or as much as is possible. So here, in these dishes, I'll bring it for you to have a look here. Look. All of my planet's surfaces will be the exact same feel, texture and depth. And I've got three bowls full of sand here. So the asteroids will be of different masses but the same size and will be in the same material that they land in. These bowls are full up to 2 centimetres. I've measured it with a ruler to keep it as accurate as possible. And I'm going to drop them from 30 centimetres. So they're going to have a drop of 28 centimetres. So all you need to do is, being as accurate as you can, once you've found what your planet surface will be for this experiment, I'm going to start off with the lightest. Let's see how the balloon goes. I'm going to drop that. And I can see the crater that's formed. Did you hear how quiet that was? Because it's very, very light. Let's see the tangerine next. Oh, did you hear that? Bit more weight behind it. Sorry, bit more mass behind it. And here, gravity is also a control variable. We're not going to different planets for this experiment. We're doing them all on Earth. Now for the pool ball. That's made a very big crater. So what you next need to do is measure your craters across using a ruler. And so for me, the lightest asteroid has made a 2 centimetre across crater. The medium one has made a 4 centimetre across crater. And the heaviest one, wow, 8 centimetres, so quite a difference. So, control variable, same size asteroid, same material for the planet's surface. So let's change around one of our control and independent variables. What if our asteroid was made of the same material but was a different size? So in your second table there, see what you can find that would be different sizes but the same mass, so that your independent variable is the circumference of the asteroid. Now I've made these out of really straightforward dough. I'll include the recipe as well. This is a 2 centimetre tiny asteroid. This is a 5 centimetre circumference asteroid. And this one, look at this, 10 centimetre circumference asteroid. Now you'll notice a source of error, hopefully, in that the way that these have baked, they are not as accurate spheres as I would have hoped. Look at that. Look, that's nowhere near round, is it? So if you come across any sources of error, please list them because they're so important. Now, the control variable again of the planet's surface, this time I just happen to be using salt. It doesn't matter that it's a different material from the first experiment, so long as all of these three are the same. That's what is most important. So, let's do this. 30 centimetres. Going to drop my smallest asteroid first. See what dent that made. Then the medium-sized one, 5 centimetres across. That was a bigger drop. And here's the biggest one. Let's see how this goes. Same height. Did you hear that? That's made an enormous crater. So I'm going to measure these again. And I'd be interested to know, do you get similar results to me or different results? Do you have different material that you're going to use for your asteroids? So my smallest one has given me 3 centimetres across. My medium one has given me 5. And my biggest one, 8. So, a different range from what I expected, but that's the whole point of doing experiments, isn't it? To see what happens. Let's change another control variable. So we're going to now make all the asteroids the same size, the same material, and look, I've got 3 tangerines now. So what will the independent variable be for this one? The independent variable is going to be the planet's surface area, to see if different surfaces will have different craters formed. This one, the thickest that I've found, I've made some kind of Play-Doh, if you like, as a surface area. I've got another batch of salt here. And for this one, for the finest surface area, I've got some flour. That's the reason I've got this lab coat on, because I reckon I'm going to get sprayed with flour with this one, but let's see. Keeping everything else the same, so they're all 2 centimetres deep, and I'm going to drop it again from 30 centimetres high. Let's see how the densest planet area copes. That's hardly made a dent there. Let's see how the salt goes. Now, of course, we've kind of done this already, so I'd be expecting a similar crater. That's worked well. And the third one into the flour. Wow, did you see that? That's gone everywhere, and it's made a very, very deep crater. So actually, my results for the planet that is made of dough is pretty much none. It didn't even dent it. Across, yeah, like last time, the tangerine has made a 5 centimetre crater. And now with this one, the tangerine has made a 5 centimetre crater again, but it's much deeper. So look, you could extend this experiment by also measuring the depth of your crater as well. So you'll find all the instructions here on the sheet. Just remember to work safely, be creative with what you can find. All of this stuff I just came across in the centre, apart from the sand that I brought in from home. And yes, have a great time learning as you experiment about weight and mass and gravity and asteroids and planet surfaces. Enjoy your lesson.